Hello, my name is Ben Costley here with Harry Ferguson and Toby Bell. This is our video presentation of our modelling assignment for integrated catchment analysis. Quinoa is a flowering plant that has been in popular demand due to its numerous health benefits. It has high vitamin and protein count. It also contains the 9 essential amino acids and is gluten-free. Its origins are from the Andes Mountains in South America, although people have grown the plant elsewhere in locations with the appropriate climate. People who have invested in the plant in other countries have occasionally failed to understand the various conditions that need to be met in order for the plant to flourish. This modelling assignment uses the content covered in Lab D of the Integrated Catchment Analysis course to create a model that can be used to determine the areas which can effectively grow quinoa within the Banks Peninsula. The software used for this project was ArcGIS.
The goal of the model was to achieve one comparable metric for all the available information for the growth of quinoa. Quinoa only grows in yellow-grey and yellow-brown soil, so anything other than these soils were not considered. To do this, an NZ soil group spreadsheet had to be joined with the soil layer in order to show which group each soil was. This could not be done in the model due to the required categories not being available after the join when it came to select them, so the join was done before the model. Yellow-grey and yellow-brown soil were chosen with the Select by Attributes tool and then made into their own layer by the Copy Features tool. This layer was then turned into a raster by the Polygon to Raster tool, so it could be included in the raster calculator. Another way this could have been achieved would have been to just reclassify the whole soil layer with any other soil equaling 0 and the yellow-brown and yellow-grey equaling 1. The rainfall was clipped with the soil layer. If it was kept the normal size of New Zealand, this would make the model take way longer, as we'd have to process the whole of the data. We'd have to process the whole of the data instead of just the required area. Slope and aspect were done by putting in the elevation model into the slope and aspect tools, and elevation was already given. These were all then reclassified into and entered into the raster calculator. Yep, here's the model.
So the model we created we deemed a success, as the data we added to the model gave us an appropriate map, so for the Banks Peninsula. The map produced could be easily read and could identify all the areas around the Banks Peninsula that could grow quinoa. So it could distinguish between the areas that were good for it, average and not at all. So the aspects seem to have a large impact on the suitability, with all the areas on the northern side of the Banks Peninsula being really good for it. This would have, the rainfall seemed to have pretty small impact due to this small variation in rainfall throughout the Banks Peninsula. This would have a large effect when comparing models from different areas or when looking at a larger region where rainfall varies. Quinoa can grow from sea level to 4,000 metres, meaning the model did not restrict the map we created for the Banks Peninsula. The model we created has various limitations, so we assume the polygon map showing the soil type is correct without using the weighted average. Rainfall is a variable that contains a lot of risk from year to year. Quinoa is a hardy plant that can handle droughts and as well as high levels of precipitation. And we've taken this into consideration with the raster calculator. Quinoa cannot handle frost during the germination stages, which could be a problem due to the South Island sometimes having prolonged winter months. The Banks Peninsula is a coastal region which could also act to oppose this frost conditions.
For the model we designed using Model Builder, we can identify the areas that are well suited to plant quinoa. We proved this by adding data collected from the Banks Peninsula region to the model. The result was a raster map showing the suitability rankings of how well quinoa grew around the Banks Peninsula. Although we're confident that the model achieved what we wanted, we also think the model could be improved to incorporate other variables that affect the areas suitable to grow quinoa. The model created can be applied anywhere in the world, considering the appropriate maps are available and the user understands the model and its various constraints. Thank you.
Thanks.
Cheer up.